Dr. Babasaheb Ambedkar Open University.
Namaskar dear students and learner of this course. I am Professor Kamesh Rawal. I welcomes you in the video lecture series of Dr. Babasaheb Ambedkar Open University. We were discussing a subject called Computer Fundamental and Information Technology. In the last session, we have focused on block number 2, right, in which we have discussed a different type of memories, an entire hierarchy of the memories which we are using in our computer system. In today's session, we will go into the detail of each memory and we will try to understand what is actually the purpose and why we are using this different type of memory into our computer system. Fine. So, in this particular session, we will focus on two type of memories. As you know, in the last session, we have just ended with two type of memory. Primary memories are random access memory and read only memory. So, in our today's session, we will try to focus on this two type of primary memories. So in the last session, we have discussed there are two type of primary memories are there. The first memory is called a random access memory or RAM, okay, and the second memory, it is called a read only memory or ROM, right. So, we will just see what is RAM and what is ROM. Okay. So, primary memories are also called as a main memory of the system, right. Whenever the user is actually inputting the data, so that data, when the CPU is processing this data, obviously some intermediate results will be produced. So, to store that intermediate results, and suppose after processing all the data, some information obtains. So, that information has to be stored into the primary memory. So, the main memory is actually storing everything, it stores the data, it stores the intermediate results which is obtained when the CPU is doing processing work, and after processing work, whatever information is obtained, obviously that gets stored into the main memory, right. Not only that, whenever we are starting any of the program, whenever we are executing any of the program, that program, that gets transferred from a secondary memory to the primary memory. Whenever you are opening any file, right, suppose if you have made your biodata, CV or resume, and obviously that gets stored into the secondary memory like hard disk or SSD. If you are doing a double click on that particular file, then that data will be transferred from the hard disk to a main memory or primary memory. Because why we need to do this thing? Because the speed of the secondary memory is too low and CPU never interacts with the secondary memory. So, whatever data is there on the secondary memory, if you want to access that data or program, that has to be copied from the secondary memory to the primary memory. Okay. Another thing, it stores instruction and data during processing, right. So, when the system, when you are executing any of the program, obviously that gets copied from secondary memory to primary memory. Primary memory is, it's an essential component in any digital computer, since it is needed for storing the program that are executed by the CPU. So, we know that when we are installing any of the program, that program's file has to be stored on the hard disk secondary memory, but the speed of the secondary memory is too low and CPU never interacts with that particular slow memory. Due to that reason, whenever you are executing any of the program, that program will be transferred from or copied from the secondary memory to primary memory, right, and then the CPU will start executing that particular program. CPU of the system can directly access the primary memory. So, obviously CPU is directly accessing, can directly access the random access memory, but CPU can never access a hard disk directly, right. Now, there are two type of primary memories are there. RAM, it is called a random access memory, and second is a ROM, which is called a read only memory. Now, we will see what is actually RAM. So RAM, you know, it is made with a metal oxide semiconductor. It is a MOS memory, right? It is made from metal oxide semiconductor memory. Now, random access memory, it allow to select any location of the memory chip randomly, you know. So, here, you know, if you have an address of a particular section of the RAM, you can directly, or CPU can directly access the data, right. So, if you have the address, then the CPU can read the data from a particular location or write the data on a particular location of the random access memory. And that is why, you know, it is named as a random access memory because here the CPU can access any random location. Okay. A memory unit is a collection of storage registers. So, here, you know, the memories are actually something like this. I will just show you. It is actually made from a small cells, you know, they are the transistors, and in a one transistor we can store a 1 bit of data, and here the memory has to be read or write in the form of words. That means the CPU can read at a time 8 bits or 16 bits, or CPU can write at a time 8 bit or 16 bit, right. So, to access that particular address, what we have is we have a storage register, right, and through the register the CPU can read a particular segment of the RAM or write the particular segment of the random access memory. RAM stores data and instruction and information in the form of binary, right. So, that is we know machine can understand what? Machine can understand only one language, and that is the language of ones and zero. I think in the previous unit we have discussed, let us suppose if you are entering any of the number, that number will be converted into the binary and then it gets stored into the computer's memory, right, computer's main memory. So, you know, in the random access memory there are small cells are there, and that cells are nothing, they are the transistor. If you charge the transistor, then 1 will be there. If you discharge that cell, then the electron will be absent, and in that case we can say it is a 0. So, you know, the random access memory, obviously it will take the data, you know, you can enter the alphabets, words, numbers, you know, image, audio, video, everything we can store in the RAM, but you have to understand that all these different format of data or information will be translated into the binary, and then that gets stored into the computer's memory, right, because in the random access memory, apart from the binary, we can't store anything, right. So, whatever data you are giving to the computer, or whether it is, you know, it is a video file, it is a audio file, it is a image, it is a text string or any numerical data, but that data gets converted into the binary, and then that binary gets stored into the different cells in the random access memory. Okay. Now, here, you know, as I said, CPU cannot read a 1 bit from the RAM, right. CPU can read directly 8 bits or 16 bits or 32 bits together, and that group of 8 bits or 16 bits or 32 bits are called a word, right. So, word is what? It is made from a few group of bits, right. So, here, you know, nowadays I think you people are aware with you know, 64 bit of system. Now, what do you mean by a 64 bit? So, obviously the current machines whatever we are buying right now, right, whether it is a laptop, desktop or our mobile phone, they are 64 bit, right. The previous generations computers are, you know, they are 32 bits computer. So, how can we say 32 bit computers or 64 bit computer? In a 64 bit computer, the CPU can read 64 bits together at the same time from the random access memory, or CPU can write 64 bits at the same time into the random access memory, right? Now you just think about a previous generation. In the previous generation, CPU that is able to read a 32-bit in a one clock tick, right? So obviously to fetch the information which is of 64-bit, it needs a 2 clock ticks, right? So right now we are using a 64-bit of CPU, and that is actually having a double speed than our previous generation, right? Because nowadays a CPU can read a 64-bit together or write 64-bit of data. A word in a memory is an entity of n bits. So obviously the first generation's machine, like if we'll talk about Intel 8086 or 286, so that are actually 8 bits computer. Then we have made a 16 bits computer, then 32-bit computer, and nowadays we have 64-bit machines, right? Okay, and that bits means, see how much bits CPU can read directly from the RAM at the same clock tick, right? Okay, data that can be available in the any form, right? So we know that there are different type of datas are there. Let's suppose data can be your name, right? Name of your university. So text based data is there. Data can be in the form of numbers. Data can be image. Data can be a video file, right? Data can be audio file. So data can have a different type of format. But once the computer, when we are storing that data or information into the computer, that computer stores the data into the main memory, random access memory, and that data has to be in the form of binary, right? So make sure RAM can stores only binary. Whatever data we can give, different type of data, but that data gets translated into the binary, and then that will be stored into the random access memory. Okay, now there are two type of random access memories are available. The first is called DRAM. DRAM, which stands for dynamic RAM, and second RAM is called SRAM. SRAM stands for a static RAM. So here there are two type of random access memories are available. One is called DRAM, dynamic RAM, and second is a static RAM, SRAM. Now here I have shown the image of the dynamic RAM, right? So you can see here one small green board is there, and on that board there are 8 chips are there, 8 ICs are there, and they are soldered on that particular board. This is called a dynamic RAM. So here whenever we are giving or submitting any of the data to the computer is actually storing that data into the RAM, and more specifically that data gets stored into that ICs which we have embedded on this particular board. So in the chip of a dynamic RAM, multiple cells are there, and which stores the data in the form of binary code. Okay, each cell is made by the transistor. As I said, transistors are small cell. You can charge the transistor or you can discharge the transistor. If you charge the transistor, electron will be there. If electron is there, that means what we can say, it's a 1. If we discharge that particular cell, then the electron will be absent, and that absence we are considering as a 0, and in that way the data gets stored. Okay, transistor which are replaced in the dynamic RAM chip lose their content with the time. So see, it's not like once you charge a particular cell or particular transistor, then the electron will remain as it is. After some amount of time, after few seconds, that electrons will be evaporated, right? And if you have charged that particular cell, but after some times if you see, that cell will becomes empty, right? And you will feel the charge that particular transistor is in a discharge mode. So now to solve this problem, to store the memory, the content whatever we have stored, here we have to put one circuitry, right? So in the random access memory, there is one special circuitry is there which will refresh the content of the RAM, and when that circuitry is refreshing the content, that means that content will be preserved for a longer amount of time. If that refresh circuitry is not working, and suppose if that refresh circuitry is not reading each cell frequently, right, Then what happen if you have charged a particular transistor, but after some amount of time you will feel that transistor is in a discharge mode, right? So to keep the content into the transistor as it is, here we need to put one refresh circuitry. And refresh circuitry is, it is just frequently reading the content of each transistor, and that actually the content will get restored, right? So here that actually that refresh circuitry is actually adding a overhead on a random access memory. Okay, so the transistor which are placed in a dynamic RAM chip, they lose their content with the time, and to preserve that content, whatever binary we have stored in the random access memory, we need to put one refresh circuitries on it, right? DRAM, dynamic RAM, is a volatile and cost effective memory. So basically here we are discussing two different type of memory, static RAM and dynamic RAM. So basically dynamic RAMs are cost effective, they are cheaper and they are volatile in nature, right? Now I have already explained what this term called volatile is. Volatile means whatever content you are storing in this dynamic RAM, that will remain as it is unless and until you are not switching your machine off, right? Once you discontinue the power supply, whatever content you have stored inside this random access memory, that every content will be erased, right? So when you restart your machine, at that time this your RAM that has to be a clear, right? Okay. The second memory, which is called a static RAM. So basically the static RAM is more reliable, it is more faster, it do not require any kind of refresh circuitry, right? But the problem with the static RAM is there are two main problems are there. Static RAMs, it needs a more space, and second, this is a costly memory, and due to that reason, in most of the computer system, that if we will talk about our PC, right, whether it is a desktop or laptop, we are using DRAM, dynamic RAM. We are not using this static RAM, even though it is having some good feature that it do not require a refresh circuitry, it is more reliable, but still instead of using a static RAM, we are using dynamic RAM, because the dynamic RAM is more cost effective compared to the static RAM. So now we will just see or read point by point. Static RAM is also a volatile in nature, so it is the same as dynamic RAM. It does not require any special register or a refresh circuitry. So here the overhead that has been reduced. Compared to the compared to the dynamic RAM, static RAM takes more transistor, and obviously if you take a more transistor to store a 1 bit, the size of the memory that will becomes a larger, right? It is more costly than the dynamic RAM, obviously, because to store 1 bit, dynamic RAM takes a 1 transistor. Here you are using more than 1 transistor to store a 1 bit. So obviously not only the size gets increased, but obviously the cost will be increased. So this memory is actually a costly memory. Main benefit of this particular memory is it is more reliable than a dynamic RAM, it is more faster than a dynamic RAM, right? But still we are using this static RAM into some specialized application, right? We are not using this static RAM into a general purpose computer or laptop, right? The reason is very simple, because this memory takes a more space and this memory is more costly than the dynamic RAM. So even though dynamic RAM has a problem with that refreshing content, and for that purpose we need to put a refresh circuitry, but still because it is a cost effective, we are using a dynamic RAM in our general purpose computer. Okay. So mainly if you have a little bit confusion between these two type of RAMs, so here you have some important points, right? So we will just summarize a static RAM and dynamic RAM. So two type of RAMs are there, one is a dynamic RAM, second is a static RAM, DRAM and SRAM. Okay, dynamic RAM, here chip must be re-energized, right? Because the dynamic RAM, it loses the content, and to protect so that it will not lose its content, we need to put extra circuitry, refresh circuitry. So that is having some extra load on the random access memory. While if we will talk about a static RAM, In the static RAM, whatever transistors you are charging, that will remain as it is. But the problem with the static RAMs are, it is a more costly. Here to store a 1 bit you need to use more than one or two or more transistors. So here the size is one problem, cost is the another problem, and due to that reason the static RAM is usually we are using in some specialized application, right. So here the summarized point between dynamic RAM and static RAMs are mentioned. Okay. Now these are the different type of DRAMs. So here SDRAMs are there, which is known as a synchronous RAM. Second is called DDR RAM, it is a double data rate SDRAM. Then the next second generation RAM is a DDR2, third generation RAM is a DDR3, nowadays we are using DDR4 RAM, right. So right now if you are buying any of the laptop or computer, you will get a DDR4 RAM, and one more random access memory is there, which is known as a RDRAM, which is known as a Rambus DRAM, right. Okay. The another memory is there, which is called a read only memory, right. As the name suggests, read only means this memory is basically used to just read the content, right. Here the system or you cannot write any data, right. So here what you have is, if we will discuss what is actually exactly the ROM is. So here ROM is somewhat it is a small chip, right. So here what you have is a small chip, and in that chip we have array, we can say rows and columns are there of some fusion tubes, right. Now see what happened when the vendor is manufacturing this particular chip. At that time vendor is writing one program. Obviously the program will be in the form of binaries, so ones and zero. Here we are using some special device, on that we will just install that ROM chip, and then we will start writing programs on that chip. Here the chip is having multiple rows and columns of fusion tubes. So whenever one is there, your fusion tube will remain as it is, and when the zero is there, we will just fuse that particular tube, right. So that tube will be erased by giving some high voltage, so that tube will get burnt, right. So that burnt part will be considered as a 0, and the part which is as it is, if the fusion tube is as it is, if it is not burnt, so in that case we will understand this is 1. So 1 means the fusion tube is as it is not burnt, and if the fusion tube is burnt, that means it is 0. Now you just think, the fusion tube which is burnt, obviously that we cannot recover it back, right. So whatever 1s and 0 is written, whatever program is written on the chip, that will not be change, right. Once the program is written on the chip, then that program, that data, we cannot erase it, we cannot reuse that chip, right. So that type of memory, once the data is written, you can read it many times, but you cannot alter, you cannot change the data or content whatever you have stored in that particular chip. That is called ROM, it is a read only memory. So as the name suggests, it is just it is a memory available for just a reading purpose, right. It stores a binary program which is written permanently on the chip. So that if you have a chip of ROM, and once you have written the program on it, then that program will remain as it is. You cannot erase that program, you cannot make any kind of alteration in that program, right. Yes, you can read that program as many as time, but you cannot change the content, right. Vendor of the chip writes the program in the chip which can not be altered. So as already I have explained, RAM is a general purpose memory. If we will talk about a RAM, obviously RAM is a general purpose memory. Here you can write the data, you can read the data, you can change the content, right. But in the case of ROM, once the program or data is written on the chip, then you can't make any kind of alteration in it. Okay. Now BIOS, BIOS, I think you people are aware with this particular word called BIOS. BIOS stands for, it is basic input output system. Now what is it actually? It is a one small chip, and this chip is actually embedded on your motherboard, right? So we know that our computer system will have a motherboard or a main board, and you know what happens when you are starting your computer, right? Because you know when the computer gets started, we know that our random access memory is blank, right? Because it's a volatile in nature. So how the computer gets started, how the operating system get booted, right? So here, how to boot the system, that program is written on one chip, and that chip we have installed in the main board of the computer system, and that chip is known as a BIOS. It is a program which every time whenever you are starting your computer system, that program will be read from that particular chip, right? So BIOS, that is called a basic input output system, which is responsible, you know, it provides the initial instructions how to load operating system from secondary memory to primary memory, right? And that chip is called BIOS, which is made from a read-only memory. Okay, so some important points about a read-only memory. Read-only memory refers to the chip which is storing the data and instruction permanently. We cannot alter it, right? Because we cannot alter that data, the name of the memory is a read-only memory. ROM is a non-volatile memory. You know, once the data or program is written, even though if you discontinue the power supply, the program and data will remain as it is, because here some fusion tubes are there, some fusion tubes are burnt. Original fusion tubes will be treated as a 1 and burnt fusion tubes will be treated as a 0. So even though if you supply the power, if you continue supply the power supply, or if you are discontinue the power supply, the content whatever you have stored in the ROM will be as it is. Manufacturer will produce the chip and then they will write the programs on it, and it is called a ROM, right? Mainly there are 4 different type of ROMs are available. The first is called a read-only memory. So here what vendor is actually, you know, manufacturing that particular chip, and vendor itself, you know, they are writing the programs on it. So that type of thing, that type of chip is known as a ROM or a read-only memory. If you think, sir, if we want to write our own program on that chip, then so yes, a blank memory module is available, right? You can buy that memory module from the market, and afterwards if you have a program, you go to any hardware vendor, that hardware vendor will write your program on the chip. And here what you have done is you have brought a new, or you have buy a new, you know, read-only memory from the market. That type of memory is known as a PROM. PROM stands for programmable read-only memory. So here you have brought a blank chip, and then you are you know, writing your own program on the chip. So that blank chip which is available in the market is called programmable read-only memory or PROM. Another memory is there which is called EEPROM. EEPROM is somewhat a memory. Here the program will be written, and that program you can erase if you are throwing some ultraviolet rays on the chip, right? So let if you have a chip, and on that chip some program is written, if you are throwing a ultraviolet rays, then the content will be erased, and once the content will be erased, again you can rewrite the program on it, and that is called EEPROM, erasable programmable read-only memory. But what happen when you are throwing the rays, the whole content of the ROM will be erased, right? But suppose if you want to erase a particular you know, segment of the chip, then we need to use EEPROM. EEPROM, which stands for electronically erasable programmable read-only memory. Here you can select a designated portion of the ROM, you can erase that particular content, and you can rewrite that particular portion, right? It will not affect the other part of the ROM. So you can select a particular part, you can erase the content and you can rewrite it, and the rest of the content will remain as it is in the this particular chip, which is called ROM. So mainly ROM is a read-only memory, PROM is a programmable read-only memory which is available a blank chip in the market. EPROM is a electronically erasable programmable read-only memory. Here you can erase the content with the help of ultraviolet rays, and EEPROM is a electronically erasable programmable read-only memory. Here you can select a designated portion of the ROM and you can erase and rewrite it. Okay, so these are the different type of ROMs which are available in the market. Then we have one more memory which is called a cache memory. Cache memory is, it's the fastest memory. It is made from the flip-flop and it is actually placed between RAM and CPU. So cache memories are actually placed between the CPU and main memory, right? And they are available in the size of KBs or MBs, and that actually, if you are putting a few KBs of cache memory, that actually enhance a lot of performance of our system. Okay. So in this particular session, what we have done is we have discussed what is a random access memory, how many different type of random access memories are there, so that we have discussed. We have discussed a read only memory, right, and different type of read only memory we have discussed: ROM, PROM, EPROM and EEPROM, right, and finally we have discussed cache memory. Fine. So I think this much discussion is sufficient for our today's session. In the next session we will start discussing a secondary memory, right. We will see what is actually hard disk, how the data will be recorded into the hard disk. Up to here we have discussed the primary memory, and now we will go ahead with the secondary memory. So we will start your chapter number 2. Till then, take care and bye bye.